In this video, we'll look at converting moles of X to moles of Y using the mole ratios from a fully balanced chemical equation. We'll start with this example. How many moles of chlorine gas can theoretically be produced from 9.889 moles of NaCl? In order to work this problem, the first thing we need is a balanced chemical equation. So I'm going to go ahead and give that to you. Let's go ahead and take this piece of information that we were given at the beginning and let's write it at the top of our T-chart. We're using a T-chart again. And now we need to identify what our mole ratio is. So we've been asked to look at NaCl and Cl2. NaCl has a 2 in front of it. Cl2 has a 1. So we know our mole ratio is 2 NaCls are needed to create 1 mole of Cl2. So let's plug that information in. We know moles of NaCl has to go on the bottom because we're trying to cancel out our units, moles of NaCl. So on the top will be Cl2. We have 1 mole of Cl2 because there is a 1 here beside the Cl2 and 2 moles of NaCl because we see a 2 here. That allows us to cancel out our moles in NaCl. When you plug this in a calculator, it will look like this. 9.889 multiplied by 1 mole of Cl2 and divided by 2. So we multiply all of the information on the top and divide by anything you see on the bottom. And when that happens, you'll end up with 4.945 moles of Cl2. A second example, how many moles of sodium phosphate could be produced from 0.627 moles of NaOH? Just like in the previous example, the first thing we need is a balanced chemical equation. Now that we have this, we can take this value we were given in the problem and write it in a T-chart. Since moles of NaOH is on top, we know we're going to want moles of NaOH on the bottom, and whatever substance we're looking for is going to go on the top. So moles of Na3PO4 will be on the top. But to find that information, we need the mole ratio. So Na3PO4 to NaOH. I see that I need 3 moles of NaOH and 1 mole of Na3PO4. So for every 3 moles of NaOH, I can produce 1 mole of sodium phosphate. So let's plug that information in, a 1 and a 3. Notice I put the 1 on the top because we were asked how many moles of Na3PO4. So we're looking for moles of Na3PO4, and the thing you're looking for goes on top. And the moles of NaOH is on the bottom because we want to cancel out the moles of NaOH. So we have moles in NaOH on the top and bottom, so we can cancel them out. Let's go ahead and plug it in the calculator, and it would be 0.627 multiplied by 1 mole divided by 3. When you do this math, you'll find the answer to be 0.209 moles of sodium phosphate. So that's how many moles we could produce if we started with 0.627 moles of NaOH. And finally, y'all pause the video and try this yourself. How many moles of aluminum are needed to completely react with 5.09 moles of oxygen? Good luck. Okay, and here is the answer. Did you get it right? I hope you did, but if you didn't, be sure you write down any questions you might have so we can address it in class. Thanks for watching.